Let's talk about percent of change. Businesses rely on percents and data to determine if they hire people or to determine if they're going to stay in business. So their investors are definitely looking at those types of things. So they might have to meet their quota. They might have to go up by 8% on their revenue in order to stay in business or either to meet their goals. Otherwise, consequences could happen. Schools rely on funding a lot of times, and that funding is based on their test scores. They might have to meet a certain percent of growth on their test scores in order to receive that type of funding. So percents are really all around you. Even the stock market relies heavily on percents. If a stock goes up 4% or down 3%, that may influence whether or not you get rid of your shares or buy more shares. So what is percent of change and how is it calculated? Well, percent of change is really nothing more than the amount of change divided by the original amount. And that original amount is your starting amount. And here's one thing to remember. There are no negative numbers on percent of change. It's always positive. So no negative numbers. It's either a percent of increase or a decrease. So all we're really going to do for that amount of change part, this part right here, is we are going to do the highest minus the lowest to ensure we don't get a negative number. Highest minus the lowest for the amount of change. Otherwise, we would get a negative number. Not that we're scared of negative, it's just we'll use a percent of decrease if it's going down, rather than a percent of increase, a negative percent of increase. All right, let's go ahead and try a problem finding the percent of change, one that you may use frequently, studying for a test. Huh? Yeah, you can actually raise your grade if you study for tests. It's crazy. Yes, I said study. Don't be scared. All right, our example is on your first test, you didn't study, and you got a 75%. Ouch. On your second test, you studied and got a 90%. What was your percent of change? All right, so for this example, we're going to do our same formula, which is our percent of change. We're just going to find out how much it changed over the original amount. So we'll take our highest minus our lowest number. So our highest number there is 90, and our lowest number is 75. So we just write 90 minus 75, and then we divide that by the original amount. Now what did we start making? In other words, without studying. On our first test, our starting amount was 75. So that's why 75 goes on the bottom. And then order of operations, I do the top part first, so I simplify my numerator and get 15 over 75. And I'm going to make my life easy before I divide. I know that 15 goes into 75, 15, 30, 45, 60, 75, and that's 5 times. So if I divide by 15, since it goes evenly, 15 divided by 15 is 1, and it goes into it 15 times. So 75 divided by 15 is 5. And 1/5 I know is the same thing as 2/10. This is just a shortcut to get this quickly and easily. And 2/10 is 0.2, because that's the way you say it, 2/10. Now I move the decimal 2 spots to the right to make it a percent, and that would be 20%. And now is it an increase or a decrease? Well, you studied, and what happened? I did better. Now you've got it. So it increased. So it's a 20% increase. Now if our score would have gone down, that would be a decrease. And that's what typically happens when you don't study. Now remember to look for those shortcuts like I did here with the equivalent fractions. You don't always have to divide. You can, because if you can make that denominator out of 10 or out of 100 or 1,000, you can easily write your decimal without dividing or using long division. I'm going to do an example where we might need to use long division to practice that. Alright, for our second example, it's about a TV. So a TV has a regular price of $400 and it will go on sale for $330. What is the percent of change? Alright, so here it's going on sale, so we know right away that's going to be a decrease. So we may not know the percentage yet, but we do know it's going to be a decrease. So let's use our same formula. We're going to do the highest number minus the lowest, so 400 minus 330. And think, what was our original amount? That would be the regular price. So $400 is what goes on the bottom, because that's our original price. And I'm going to simplify that top first, so I put that in parentheses, and 400 minus 330 is 70 over 400. And before I start dividing, I see right away if I divide by 10, that just gets rid of my zeros. So it's really just 7 over 40. I can't simplify that anymore, so I'm going to go ahead and do long division. So 7 divided by 40. Remember, you say it forwards, but you write it backwards. And 40 won't go into 7, and it won't go into 7. It will go into 70 one time. So 1 times 40 is 40. I subtract here, and I get 30. I bring down another 0, and that will go, the way I think of this, 4 will go into 30 is what I'm looking for. So 4 times 7 gives me 28. So I'm going to try 7 there. And 7 times 40 is the 28 plus the 0, 280. Subtract again, and I get 20. Bring down another 0, and now I'm in luck, because 4 goes evenly into 20. So I say 4 times 5 is 20. So 40 times 5 is 200. And I have no remainder, so I'm done. So that would be 0.175, or as a percent, that's over 1 over 2. That's 17.5%. And we already know it's a decrease because the sale price means it goes down. Alright, so enjoy watching your TV? Well, you don't have to enjoy it that much. Look, your eyes are bloodshot. Stop watching. Alright, well, let's try another question. This one you can try on your own. Alright, go ahead and pause the video, copy this down, and try it on your own. Find the percent of change to the nearest tenth from 24 to 26. Alright, and now for the solution. We'll check what you got. So, looking at the word from, I know that's my starting amount, or my original amount, and then 226 implies that that's my new amount. So, in my formula, I do the amount of change, so 26 minus 24, all over the original amount, which is 24. I subtract to get 2 out of 24, and I'm going to be smart and reduce that to save me a little time, and that becomes 1/12. And now 12 won't go evenly into 100, so I'm just going to go ahead and do long division. So 1 divided by 12. 12 won't go into 1. It actually won't go into 10, so I put a 0 up there, but it will go into 100. 12 times 8 is 96. I subtract and I get 4, and then I bring down another 0. 12 will go into 40 3 times, and watch what happens. I keep getting 4 as a remainder, which tells me I'm going to keep getting 3 up here. So I continually get 4 as a remainder, which is 3 up top. So it's really going to be 0.083 repeating. But since this says round to the nearest tenth, I'm going to go ahead and write it out rather than with my repeater bar. And I'm going to move that decimal 2 spots to the right to make it a percent. So it's 8.33. I look to the number to the right of the tenths, and it's less than 5. So that means I keep it at a 3. So I'm going to erase that 3. It's just 8.3%. And what did it do? Did the number get bigger or smaller? It says from 24 to 26. So it got bigger. So it's an increase. All right, hopefully you got that. And that's going to wrap it up. Remember, percents are super important. The world that we know depends on them. And hopefully now you can better juggle your percents.